We'll only go through questions that you got wrong. So, question number 1, anyone got wrong? Question number 1, anyone got wrong? Question number 2, you are 2 with it, or you're 1? Yeah, okay, number 2. Okay, let's look at question number 2 here, guys. If you look at question number 2 here, it says that the table shows the reading of a car speedometer at 5-second interval, right? Every 5 seconds that passes by, the speed of the car is increasing. And as you can see, the first jump was 30, the next jump was 20, the next jump is 10, and the next jump is 5. First question, is it accelerating? It is definitely accelerating, right? Is it decelerating? What should we write this? It's decreasing acceleration, because the jump becomes less and less and less. So obviously, first one here is anything that has speed decreasing one. I need to beat you. Do you write any A or B? Oh, good. If you didn't, then it's most likely going to be C along here, right? Which the acceleration cannot be 0. So it's definitely not 0. There is still acceleration, just decreasing acceleration. Okay. Then question number 3. Anyone got wrong?
No.
4.
I got 5 wrong.
4, no one. 5. 5. I see this a lot of students. For some reason, I haven't taught you guys this, but a lot of you guys circled resistance as the answer. Which teacher teach you one? Why do you guys circle resistance as the answer?
I circled density because it says like it's same metal, Sorry.
It is the answer. How come you got it wrong?
I got it wrong.
What?
No joke.
Bro, this is correct, bro.
Oh,
Next question is wrong, bro.
Bro, tick location. I am actually.
Bro, the answer is density, because density is dependent on mass and volume, right? Since both of them have the same cross-sectional area, but one is longer than the other. Oh, sorry. What? Sorry. The keyword here is because they're made of the same metal. Like for example, the water on Malaysia and the water in Japan will have the same density, right? Because they are the same material. Same thing, like the metal in Malaysia and the metal in Japan will be the same, right? Because they are the same. And since this is the same metal here, then obviously the density should be the same, not the resistance. Definitely not the mass and definitely not the volume, if I think about it. Yes. And then question 6, some of you guys got it wrong. A heavy beam rests on 2 supports. The diagram shows only 3 forces, F1, F2, F3 acting on it. The beam is in equilibrium. What's the condition for anything to be in equilibrium again? No resultant.
No resultant
forces and no resultant
moments.
Right. So you look at the scan through the answer and which one has no resultant force and no resultant moment. The resultant force on the beam is 0. The resultant turning effect, which is moments, turning effect is essentially a moment, right? On the beam is 0. Then wouldn't this be the answer? Equilibrium. Okay. And this one here. I see some of you guys got this wrong. So how many of you guys got question number 7 wrong? Yes, I know. You also. You also.
Yay.
Most likely your sequence of thought was this. A is very small. B is very fat with a fat surface at the bottom. Then it's more stable already. But guys, on top of having a large surface area at the bottom, the center of mass should be lower. Thus, your answer should be donkey.
Alright, that one's careless.
Yeah, this one, if you lose this one, it's GG.
Let's not talk about questions.
Let's not talk about questions. Circle that the center of mass is here, guys. Guys, I want you to think about this in terms of moments. Let's say, right, the center of mass is here, right? And I already have one guy standing on this platform here. And in this scenario, where would the pivoting point be? Here or here? The first wheel or the second wheel? Where would the pivoting point be in this scenario? Number 1 or number 2?
The second wheel.
The second wheel, right? If, let's say, this is the center of mass, right? And there's obviously another guy here. According to your moments understanding, there's a force and a perpendicular distance. There is a force and a perpendicular distance. Wouldn't this create a clockwise moment? Right, and then this guy is obviously going to smash his head to 1,000 pieces or less. Right. So Where could the logical center of mass be? The logical center of mass must be here, right? Because if this is a distance to the pivot, it will generate an anti-clockwise moment, and this guy is obviously generating a clockwise moment already. These two things will balance out, ma. Right or not? Right. So GG for C for sure. Is B, yeah? Yeah. Okay. Yeah. Question 7, anyone got this wrong? Sorry, question 9, anyone got this wrong? Yes, the graph represents the motion of a car. This is a speed time graph. What is the distance traveled by the car moving at constant speed? And which part is moving at constant speed? From which time to which time? Ethan, from which time to which time is the car moving at constant speed? No. Zero. Zero 哪里有？这边它是 increasing speed 来看，对吧 ？So this is definitely not constant speed， 而 constant speed 就是说是 fixed 的，它的 speed 没有改变啊。So which one is constant speed? From where to where? Yeah, the straight line here lah, right? 15 to 25 ma. And in a speed time graph, how do I find the distance traveled again? The area under the graph means to say, for Ethan, I'm supposed to find the area under the graph here, right? Right. So it's essentially it will be like this is 10 and this is 10, right? Which the answer should be 100, right? 10 乘10. Question 10. Anyone got this wrong? Okay,
Yes, you know, yeah, it's the same. I hope. That's how scared I was. I hope. That's how scared I was.
Math doesn't change, right?
I was like, it's the same. I hope.
Okay, then after that, the next part here, they ask for acceleration, which I see some of you guys either do the wrong calculation. I think it was you, right?
Yeah.
Yeah, or you wrote the wrong units, then you also get your marks minus. In fact, right, I see a lot of students they totally skip this question. They didn't even see this question was in the paper. What? Where should I mark this? Mark a point P to indicate a time when the acceleration of the sled is not constant.
It's 120 meters per second, right?
How do I know from this graph that it will have no non-constant acceleration? How do I know? Which part of the graph tells me the acceleration in the speed time graph?
If it's curved, that means it's not.
No, wait. What component of a speed time graph tells me the acceleration?
The graph.
Which component of the graph?
The line.
No, the what? The what? Wait, bloody hell. Just how the distance, you know, find the area under the graph, right? In a speed time graph, how do I find the acceleration? The gradient. Guys, the gradient from a speed time graph tells me the acceleration of the graph, right? Of the object, right? So if I have non-constant acceleration, the gradient should be
not constant.
Non-constant also lah, right? So is this part constant gradient?
Yeah.
Yes, because it's one straight line, right? Is this part non-constant gradient? For sure lah, because it's curving, right? If it's curving, it means to say the gradient is increasing or it's decreasing, right? So if you label anywhere, your P, like here, 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 or here, as long as it's at the curving part of the graph, you'll get your mark for this one. I think you skipped this question, right? You didn't even see this one. And you forgot about it. Good. Then after they want you to find the acceleration of the sled. Acceleration, you're actually supposed to do this our way. You're finding here, then you're finding here. Here is 1, right? And here will be 40, 80, and then 120 and 160 here, guys. Anyone, by the way, anyone don't know how to find the intervals between the 0 to 200? Anyone? Everyone knows, I hope. Right, so it's like 40, 80, 120. And if you find acceleration, which is v minus u over t, right, that will be 120 minus 0 over 1 now, which is going to give you 120. What's the units?
Meter per second square.
Yeah.
Wait, why is square? I don't remember this.
Because this, okay. Because v minus u over t, right? V's units is what? Meters per second. And times unit is what? Second, right? This is essentially meters per second divided by second, right? If I write it down into the normal fraction that everyone is familiar with, meters per second divided by second is the same as meters per second multiplied by 1/2, right? Which is going to give you meters per second square, right? Okay, but good question. Hey, remember this? Actually, you're not supposed to remember the units. You're supposed to like literally do the calculation and find it yourself, guys. And later on, you're going to encounter more formulas with more random units, which you are actually supposed to do the exact same thing. So identify each component's unit, then you do the mathematical way to find it, and you'll get it. Okay?
Yes.
Good.
Yes.
This is one of my favorite things. Java chip cookies.
Yeah, I also love Java chip cookies.
Would you have preferred boba over this?
No, I hate boba.
Yeah.
I'm the rare Asian guy that doesn't like boba.
So it's 120 meters per second square. Okay. Then after that, this question also, I see some of you guys get it wrong. From 1 second to 2 seconds, they want to find the distance. How do I find the distance again? Janelle, how do I find the distance in a speed time graph again?
Oh no.
Very good. It is the area under the graph, meaning to say you either find the area through the trapezium here, or if you forget your formula for trapezium already, you use the area of a triangle with the area of the rectangle, and bam, you have gotten the answer already. Which you're supposed to get 180. Anyone don't know how to find the area here? Did you get this one correct? Did you get this one correct?
No.
You got it wrong again, bloody hell.
Top scorer. How did I get top scorer? I have no idea.
Your back theory part carried you a lot. The theory part, a lot of people wrong, especially the spring constant one.
Oh, spring constant.
Yeah, a lot of people got it wrong. I think you got full marks right for the last question. Close enough. You were the one talking. Okay, and then this question, which a lot of you guys actually got it wrong. No fiction. You got it right? Yeah. Who else got it right? You got it right? You got it right? Good. Guys, listen, this one here, it says that you're actually supposed to apply a formula. It says that the resultant force acting on the sled remains constant. This is the first key thing. And I say that suggests why the acceleration is not constant. Okay, so what you're supposed to do is you're actually supposed to apply the information. They say that the force is constant, right? If you follow the F equals to ma formula, if this thing is constant, the only way for this thing to increase or decrease is that the mass must what? Change. Must increase or decrease. For example, if let's say, right, the acceleration is increasing, the mass must what? Increase or decrease?
The force increases on mass.
No, the force is constant already.
If the acceleration,
Yeah.
Wait, but how does the mass decrease though? Like,
Okay, good. Guys, before we even go to how the mass decrease, if you're having difficulty understanding how this thing works, you can plug in fake numbers for it. Like for example, what I usually like to do is, right, if force is constant, right, I'll just put like 10 newtons, 10 newtons. Okay, and then let's just say the acceleration is increasing, right? Let's say from 1 to 2. Okay, then the mass is actually going to decrease from 10 to 5, right? You can plug in fake numbers to illustrate your understanding if you are uncertain. So I know for a fact that when your acceleration increases, your mass is for sure going to decrease if the force is constant. You get it? I find this practice quite useful in a lot of scenarios. Later on, especially when you do electricity in year 11, you'll need to plug in a lot of fake numbers to help you understand better. So the next question is, how will the mass change if the sled is being shot? Guys, if you look at the question here, it says that this sled is like moving on a track, right? And you can obviously see this fire here, right? If you think about it logically, this thing must run on what?
Oh, I see, because like the petrol tank is like going down.
Yeah, it's running fuel, right? As this thing continues to move, because the engine is going to give you a constant force already. The engine is fixed, right? The engine is not going to spin faster or spin slower if you step to the maximum, right? So the only way for this thing to accelerate faster is for it to have decreased mass. And if you think about decreased mass, it must be due to the fuel that is constantly being consumed. You get what I mean?
Why is that? Why we use like hydrogen gas?
The same thing also, right? The hydrogen gas is going to take some mass, right? You know, like for example, you guys got stove at home, right? You know those guys that come change the stove?
Yeah.
When it's fresh, that stove, the gas stove is the heavy one, you know. And then when they change it, you finish already, your parents will call the gas stove guy and they'll come change, right? The thing becomes much lighter one. Even though it's gas, it still has mass because accumulated gas will still have accumulated mass.
How about like let's say solar energy like Tesla like that?
Bro, that's a totally different story. Solar energy is like where the mass. Photon only.
Exactly.
But this one is confirmed got mass because it's fuel. Right. So your idea is that you need to understand that the fuel is decreasing.
Actually, guys, photon is
Fuel is decreasing as the slab uses and acceleration. Actually, if you just wrote the fuel is decreasing, you get your mark already. But I'm just writing more for you to understand.
I think it'll be a nightmare to stop this thing off in the way.
Okay. Everyone? Yay! Next. This one, I think most of you guys got this correct. A scala is basically things with magnitude only. It could be speed, distance, time, temperature.
Like gravitational force cannot. Right?
Cannot. Force is a vector. Force has direction. Literally anything that you can think about, but I can't think about anything. Oh, energy, pressure, right? All these got no direction on. Right, you wrote any of this is correct, but for me, I would have definitely written distance because it's the easiest scalar quantity, and the vector I would have written displacement on, which is the first thing I taught you guys in class. Distance, displacement, speed, velocity, acceleration, all these then you know already. And this one here, I think this one you were the one that wrote something funny, right? You got this one wrong, right? What's the formula that I'm supposed to use? Hey guys, when you do all these calculation questions, you need to identify what's given, right? Like for example, if let's say today, right, I want to make a chocolate cake, I won't go to the damn supermarket and buy bananas, will I? Right? If you look at this question here, what information, what ingredients do they give you? They give you mass, they give you force, and they ask you for acceleration. Some of you guys wrote a very funny calculation or funny working, guys. First and foremost, if you see these ingredients here, then you should think the formula should be F equals to mA, which is bloody.
Oh no.
It's like
This is definitely
it's right. Information here, you're given the mass, you're given the force, you must know the acceleration.
You know, I got it correct. I was like, this number looks wrong, so I'm not gonna write it.
GG.
Oh my god. GG. Bro, I lost part of my soul after looking at that.
Then your A, algebra, which for some reason also got a problem. Some of you guys do algebra. Some of you guys dare to write force over mass for me. Was it you? Was it you? It was you, Bloody hell. This is algebra, bro. FOM. You know, right? This M is bringing downwards here, right? Then from here, what do? Then after that, some of you guys literally, right, don't see this K here. What does K mean?
1,000.
1,000, right? So it's
If you watch enough studies, you know.
1,000 over 9,000. I press in the calculator, you get 0.17 something.
Bro, if you watch enough Mr. Beast, you know what K means?
Don't know.
I'm not kidding, man. You uses it so much.
Okay, then you get your 3 marks. This one, wow. Marks, eh. Okay, then next question. This one here, okay lah. I could argue and say that this question, I put it there on purpose because I wanted to test who was paying attention. Which, sad to say, most of you guys got it wrong. How many of you guys got 4 out of 4 here? I think none of you guys got 4 out of 4 here.
I got caught
You?
at the beginning.
How many did you get?
1,
2.
Huh?
I think you were the closest one.
2 out of 4. I was cut from the beginning of the because I didn't know the label the nicknames.
Okay, anyways, look at the question. Okay, what is the question one from you? You need to understand what's going on first, guys. It says that figure 2.1 is not to scale. So drawing on this is already wrong already. I saw some of you guys, was it you drawing on this? Oh, okay. All right. You could use this for understanding. You could use this as a mini map, but if you draw on this, you're already wrong already. Show the view above from the boat. Now it's fast flowing river. The boat accelerates. Okay, so this is the boat direction. The boat is accelerating. 2 force acts on is shown acting on the boat. The resultant force is at right angles to the river bank. Right. So if you think about it, right, there's one force acting here. There's another force acting here. Then the resultant force should be where, Olivia? In between, right? So it could be either here, 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 or here, right? But they already said that the resultant force is right angle to the riverbank. Means to say it can only be like this, right? Right. Then after that, most of the time, the exam they ask you, they give you this, they'll give you this, and they'll ask you to draw this. But in this question, they gave a totally different scenario. They gave the resultant force, then they asked for the force of the river, and then they ask you to calculate. What did they ask you to calculate? Incomplete vector diagram. The force on the river is 80,000 newtons. Force on the river current. This one here is 80,000 newtons already, which is to scale. This one is the one to scale. Right. And then they ask you to determine the scale to use for the vector diagram. You know what you're supposed to do? You're actually supposed to use a ruler, measure like from the tip of the arrow to the end of this thing here, and measure how long this thing is. Everyone measure right now and tell me how long is it?
4 cm.
Exactly 4 cm.
Right.
Wow, this printing so true. Usually a bit off. Is it 4 cm? How much do you get? 4.2.
Let me find out.
Oh wait, you printed yours. Is it 4.2?
I got hold on. I got
Why
4. Yeah, no, hold on. 4.1. 4 whatever lah.
4.2. Why everyone's different? Okay, give me a paper. Yeah.
Bro, don't this is a dog, bro. You just do different. Don't see it.
Oh. It's around 4.2.
Bro.
Wait, you printed a different paper, I hope so, right?
Me?
No, her and him. Yeah, so it's 4.2. So in this scenario, but in the real exam it would have been 4. But in this scenario, if we follow by the question, guys, 4.2. Hey, look here, 4.2 cm represents 80,000 newtons. Then 1 cm is representing how much?
80,000 times over 80,000 over 4.2.
Yeah, 80,000 divided by 4.2.
Because
Press that in the calculator, how much will that be?
a lot.
Damn a lot, but give me a value.
The value is one ratio to 15. Well, let's see what the thing is 15. For the 4 zeros. Here 1904.7.6 1905.
One what?
I'm not kidding. I'm not kidding.
19. Okay, 19.
Okay.
Okay. Okay.
I think you gave him a you gave him a
Okay, so in a real exam, the printing would have been more standard, and this would actually have been 4 cm. So in the real exam, 1 cm would have been representing 20,000 newtons already. But for this scenario here, you're literally supposed to get it like this. Okay? And you're supposed to get 1 cm represents 19,047 newtons.
Now what is the
Or even if you round it up to 1 cm represents 20,000 newtons, I would have given your mark.
Yeah, 20,000 now.
Right, which was the easier one up. But if you did it by the calculation, you have gotten this 19 blah 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 blah. But if you wrote 20, I would have given you the mark. How do you get 10,000? Oh, give your mark.
Accident. Accident.
You will get 100. Because you have
Very friends. Very friends. Please. Yeah, he's a furry.
Stop playing the phone. Okay, then after that, they say complete the vector diagram to determine the magnitude and direction of the force from the engine. You're supposed to find out how much this was, right? Because this was the force from the engine, right? Right. Then you're actually supposed to, I see some of you guys, you do something funny also here. Some of you guys, you connected from here to here, which is wrong. Okay, and some of you guys drew like this to here, which is wrong. Because they already showed that this is the direction, right? This way, right? Towards the 1 o'clock direction, which can only be connected from here to here. Like the tip of the arrow to the other tip of the arrow. You're supposed to draw this line. If you drew this line, you have been correct. Then after that, you're going to measure how long this thing is. Hey, measure how long this thing is. From the tip of the arrow to the tip of the arrow.
Alright, from arrow tip.
No, you were that guy.
Hand work properly, please. 12.1.
12.1.
12.2, sorry, 12.2.
Is it? Confirm?
Wait, hold on. 12.2. Wait, hold on, remove. No, 12.1. I mean 12.1, yeah, 12.1. It's supposed to be 12 centimeters, right?
12.1?
It's definitely supposed to be 12
Yours
centimeters.
and yours will be different. We'll follow the 12.2. So here is 12.2 cm. Okay? If it's 12.2 cm, then you're supposed to find using this right just now. We go, oh shit, the number 19,047. Okay. If this is 12.2, right, I'm supposed to find the magnitude by like this, right? So I actually need to take the 19,047 times 12.2, which will give you something. What's that something?
$373.4.
23. Okay, the raw number would have been 232373.4.
What?
And 4.
Apa ini?
23,000.
That by right should be impossible.
23,000. Correct.
100. I got 112,000.
It may be correct. Let me just double check. I think it may be correct. Yeah, it's 230,000 or not 23,000 or. Say your answer again. What was your answer?
232373.4.
232373.4. Oh, this is 200,000. Yeah.
Yes, sir.
So your engine, because you can only write your answer in 3 significant figures, until today, I still see some of you guys wrote more than 3 significant figures, which you are wrong already. So your answer should have been 232,000 newtons already. Or something along these numbers already. Okay.
Okay. Oh, that's so awkward.
And then after that, they want you to measure the angle, right? I also don't know why most of you guys got this wrong. The angle between the direction of the current and the force. The direction of the current is here, right? The force is here, right? So you're actually supposed to measure this angle, right? How much is this angle? How do you get 70? Eh?
No, I measure this angle.
Oh.
I know. If I measure it here, then angles are measured over here.
GG, you didn't even read the question.
I measured here, I didn't measure here.
How much is the angle?
Protractor.
Bloody hell, no one has protractor.
Here's protractor.
You're supposed to get somewhere around 110. You're supposed to get 110 degrees. Anyone cannot find 110.
110.
Yeah, it'll be somewhere around 110, right? If you have a protractor or yeah, protractor.
Bro, I was like, protractor.
Okay. Everybody? Good.
Random prediction is gonna read today.
I want to bring my bottle line. Okay, anyways, next. Who got this question wrong? I want to beat you right now.
Oh no.
You are.
Discrimination.
I literally put this on here. This one was you. We literally went through this question together, in fact. Do you remember? Or maybe it was the first day. But we definitely went through it, right? You were here, you weren't here yet.
No. And I still got it.
Question. There was Chenny and Emma.
Guy. You are.
There was 4, right? When you first started. Oh, it's Ian, right? There was a go. Good memory, Gabriel. Anyways, from here. I don't know what this one. This is the mass, this is the density. You're looking for the volume. That obviously is mass over volume, right? Then you do your algebra correctly. You'll get volume equals to the mass over density. Then you go 200, divide by 8.4, then you get a very weird number, 23.8. Or 23.8. Yeah, so it's 23.8. What's the units?
Centimeter cube.
Guys, listen up. In a normal scenario, your volume should have been meters cubed, right? But because this calculation uses grams and grams per cm cube, you know why this will end up as cm cube, right? Because this is in gram divide by grams per cm cube, which will ultimately give you grams multiplied by cm over gram. That's why you end up with cm at the end of the day. Like mathematically, you can prove that this answer will be in cm cube, guys. Oh. Okay, and thus your answer will be in cm cube. And if you wrote three significant figures and below, you have got your mark already.
I need to thank my English teacher to teach me how to write so nicely.
Okay, then next, this one here. I think most of you guys got this one correct. The wood does not sink in the water. Whenever I said this before in your exam, if you see the word sink or float, your answer better sure has density inside. The only reason why something will not sink is because it's less dense. The only reason why something will sink is because it's more dense. In this scenario, I say it does not sink, right? Then you say that the piece of wood is less dense. And bam, you get your 1 free mark already. But then, right, the funny thing is when you enter this next part here, everyone already said that. Most of you guys got this correct, I think. Everyone said that the wood is less dense than water, right? But when we do this question here, a lot of you guys, right? Oh, place the wood in the water and see how much the water displaces. Bloody hell. What are you? You again.
Oh my god. I speech plus 100. Speech plus 100.
Bro, you already said the wood is less dense than the water. How do they put the wood into the water? They even give you a brass, right? Somewhere around this there. Shit, where was it? They give you a brass object, right? So what are you supposed to do? Guys, the scenario, in most scenarios, if you have a irregular shaped object, you just place the thing inside, then you see how much the water goes up and you can find the volume, right? But if the thing doesn't sink, then you tie the piece of wood with the brass and then drop it into the water. Right? When you drop it into the water, when you drop it into the water, you have the volume of these two things, ma. Then after that, you need to find the volume of the brass. Then you can minus both of these things out and you'll be able to find the volume of the wood already. You understand what I'm talking about? So, you sure? Janelle, do you guys want correct?
I mean, we did do it in school.
Literally did it here also. Some of you guys still get a funny answer.
Wait, we did it? I mean, like the actual experiment. Bro, I wanted to ask my physics teacher then. Yep, I bring these things.
Was it you? The one the water one? You were the one, right?
Water?
Yeah.
Water, right?
Anyways, if you want, you can check the answers for the water one. These are the keywords you need. You need the volume of the wood and the brass.
Oh no, the last one. What? There was nothing we can do. There's Napoleon, there's nothing we can do.
If you want, you can check your book for this question also. I think we have the same question in the book. Okay. You done? You done? Okay, I'm fine.
Bro, this one is better than Ariana Grande, man. Once again, thank you, Max.
Yeah. And the next one is they already tell you the spring, right? Bloody hell.
He's saving the numbers, this one.
My notes already give you the spring constant drawing already, right?
Not saving the summer.
And in fact, I think most of you guys were drawing this also, but what's the difference between this graph and the one that you see on your exam question? Terbalik, yes, the axis are terbalik. This one is a force versus extension graph. This one is an extension versus force graph. That's why you see just now that one it curves like this. This one it curves upwards like this, right? So, but anyhow, they say that the first part obeys Hooke's law, right? So you just draw one straight line now. Because it's directly proportional, right? I think most of you guys got it correct. For this part here. Yeah.
Yeah.
Then after that, they ask you to say name point D, which most of you guys got it correct also. You know that's the elastic limit. Or if you put the limit of elastic proportionality or something something that makes sense, I give you a mark already.
Gravitational limit.
Huh? You wrote that?
No, obviously not. Funny idea.
Okay, then this one work done you haven't learned, so you can skip this. Then they ask you for the
Everybody will teach what done.
Huh?
What chapter?
Next one.
Oh, I see.
After momentum.
Okay,
then after that, they said the spring is unstretched at 4 cm. This is the original length, by the way. And they say the hung from the spring increased from 4 to 6. How much is the extension?
2.
The extension is 2 from here, not 6. And ask you to calculate the mass of the object. So if I find the extension is 2, right, then I first and foremost I need to find the spring constant here, right? That's why it's worth 3 marks. How do I find the spring constant from this information here? Okay, listen up. Right now they ask me for the mass, right? If you think about the formula for Hooke's law, is F equals to Kx. Okay? I already have the extension already, which should be here. In order for me to find the mass, I need to convert this force into the F equals to ma formula, right? Or betterwise known as W equals to mg. Guys, listen up. When you're asked to convert newtons into kg, you always use the W equals to mg formula. Because this weight and force, they are the same thing. They are both measured in newtons. Okay? So if you're asked to find the mass, you most likely have to convert the force into mass using the W equals to mg formula. Okay? So first and foremost, I also need to find the spring constant, right? So there's a lot of things to do here. But first and foremost, how do I find the spring constant from here? Duncan, how do I find the spring constant from here?
F equals 3x.
Oh, then
Look at the graph, then Use the graph.
K equals to. What's the formula first? You arrange it.
K. I saw for K.
Yeah, but you need to rearrange the formula first, right? What's the algebra rearrangement for K? F over X, right? So from here I can find the spring constant, right? It will be 12 divided by 3, right? Which will give me 4 Newton per cm. This is the spring constant. With this spring constant here, I can substitute into here, right? Because F would have been 4 multiplied by 2, right? Which would have been 8 newtons, right? But this is not the final answer because this is in newtons. I need my mass, right? So it's basically W equals to mg, or M would have been W over G, which in this case will be 8 divided by 9.8. Then you'll get the answer already. Something.
Yeah, what's the answer? 0.815.
Very good. You're the only one that got this correct, I think.
Give shout out to Duncan. So is there a train station nearby here on this place?
Down the road.
Oh.
Not really down the road, quite a bit distance away. Why are you walking?
No, I'm just curious only. Later next time I got like jam like crazy. I use LRT go home now.
You could, but you'll need to take a train. You need to take a Grab to the train station though, because it's not that close. I think it's like maybe 2 km away.
Yeah, that one can walk 2 km.
Yeah, like I can, but if it's raining,
take umbrella.
wow, man with many solutions. Wait, what's the answer?
0.815 kg.
0.815. And it should be a kg. Yes. Yay, then the final one here. The object is immersed in the liquid but remains suspended by the spring from the spring. The liquid exerts a force on the object and the length of the spring decreases.
So no
to
true.
5
I
cm.
didn't use any formulas for this one. I just like simply do myself. I just DIY on. I completely DIY the question. I'm not joking.
Actually, this one here, if you think about it, right? 8 newtons causes the thing to extend by 2 cm. Then if it's from 4 to 5 cm, it's basically extension of 1 cm, right? If you think about it, the upward force must be 4 lah, but you can do it from calculation also lah. So guys, if this question looks long and confusing, you identify part and part of the first. They say that the object is immersed in the liquid, but but remains suspended from the spring. So the first information is that, oh my god, have I been sharing this screen? GG.
Imagine shares like a total gameplay the entire time.
Oh my god, the guy that is watching the replay is gonna get it. So there's a spring here.
Wait, the League of Legends.
This now was 8 Newton, right? And right now it's suspended in water.
Do the math yourself.
Right. And then just now, it caused it to extend. The extension just now was 2 cm, right? Right now, after you put in the water, the extension is 1 cm only. Right. If the extension is 1 cm, they're asking for the upward force from the water. How much do you think it will be?
4 newtons.
It must be 4 newtons. The force must be 4 newtons because right now the extension is only 1 cm. Because even if you use the calculation, F equals to kx, right? Your F would have been 4 multiplied by 1, which is also going to be 4 newtons here. If you do the calculation. But if not, if you look at it, you'll notice that it's actually going to be 4 newtons.
All right. Okay,
everybody. Anyone has any questions with regards to the aircon feels so hot today?
It's 17 though.
Is it on? Do you guys feel it?
No.
What?
Impossible, this one. Cold-blooded. Hey, banker, send a poker.
So it's 4 newtons.
One token, how much?
Alright guys, that's it for this one here. Anyone has any questions about
Hey, banker, how much per token? I forgot the values of all the tokens.
If no questions, this is what we're gonna do today, okay? We're gonna play the rest of
poker. Play poker.
Okay, let me explain a little bit on how momentum works first, guys. If we have time, we're going to go through the notes, but let me tell you the concept of what momentum is first, okay? Momentum basically states that there are two things that affects a momentum. If you think about it, right, today, if let's say me and Duncan were to run at the same speed, ramming into Javen, who's going to hurt more? Same speed, both all running at the same speed, ramming. Yes, good. I'm heavier. Sorry?
Both of us are going to hurt.
I know. He's
The immovable object.
Okay, why does he hurt more? Is because momentum is dependent on two things. Momentum depends on the mass and the velocity. Obviously, the higher the mass you have, the more momentum you're going to build up. That's why fat people of heavier people, right, will have a harder time to stop immediately if we start running. Okay. Alternatively, if let's say he runs very, very fast, okay, he will also have a very hard time stopping immediately because his velocity is high and his momentum is high. Okay. Now, momentum has many, many applications. If you think about the application of momentum, right, which I love to tell my students, is imagine today, I want you to imagine today you're in a zoo. Okay. And then you are a little bit playful. So you go to the elephant den and you keep teasing the elephant. You know how you tease the elephant? You keep taking like a card, right, and say, as soon as you try to go, you snap it back and then you just like make some funny noises, which is exactly what I did to the monkeys in the zoo.
I mean, the monkeys are not.
They were angry.
Monkeys are not that nice.
So I kept taking like all the useless name cards, right? I said, you can't take it. As soon as I pitch, I'm grabbing it. It's like shaking the shit.
That's so cool.
They were really.
I mean, the vegans are hate you, but I want the vegans to hate you.
Oh man. Okay, so imagine instead of monkeys right now is the elephant, you keep doing that. Okay. Wait, listen first. Sorry, okay. So what happens is right later on, right, while you're playing in the zoo, right, suddenly the zoo malfunction. Shit. All the cage, right, all open up already like a prison break kind of. Okay. You all know that elephants are very memorable creatures, right? As in their memory is very fun, you know?
Yeah.
You guys sure know, right? So imagine today, right? The elephant is out from the cage already. A poorly illustrated elephant, but an elephant nonetheless.
Oh my god, what a big elephant.
Okay. That looks like a gremlin, but it's an elephant.
I mean, it's a thing from Game of Thrones.
Okay, it's an elephant. And then there's you here. Okay, there's you here. Guess what's the elephant gonna do?
It's gonna run.
It's gonna run at you.
Gonna die.
And it's gonna ram you straight to hell, right? But of course, if you're dumb, right, then obviously what you're gonna do is the elephant run at you, you just run at a straight line. This is one ticket to go to hell straight away, because first and foremost, the elephant runs faster than you, and second is the elephant is much heavier than you. He will definitely kill you, but not today, guys. Why? Because you're a man of science and you understand momentum. So what you do is, right, every time you run this direction, as soon as the elephant is about to catch up to you, you initial drift. And you drift.
Initially.
And you know what's going to happen to the elephant? Because the elephant has a much higher momentum, he will take a much larger distance before he can turn the distance here. And as soon as he runs and almost catch up to you again, you initially drift again. And what's going to happen to the elephant is he's going to take a much harder time to turn because he has a greater momentum, and so on and so on. And eventually you just zigzag all the way until you outplay him and then go break him and you'll be safe.
And go break him.
With the power of science. Okay?
Stop the stone.
So there are many other applications of momentum. Like for example, if you see the magician, right? They place a lot of shit on this table here. And then there's a table call. And I say 1, 2, 3, 1, 2, right? All the shit is still on the table. That's also an application of momentum, which is exactly what we're going to be playing today. Okay, so you can see here, right? There are a lot of shits here. Okay. So the idea of momentum is that if your momentum is actually fast enough, if your momentum is fast enough, right? So momentum, just now I said momentum will cause the elephant to move in the same direction, right? It will be the same for in non-movement objects. In a way that any object that is already in motion will stay in motion. Any object that is stationary will stay stationary.
I was saying like you're taking like the thing instantly.
Yeah. So what you can do is you're gonna stack rows and use chips together. right? Preferably in a very nice foot manner because
OCB.
no, not OCD, and I need to learn. I wonder if this ruler is going to be hard.
No.
And then with the application of momentum, what I'm gonna do is oh shit. Oh shit. Oh, there's something longer. Good, something like this.
No, this is like a baseball bat.
No, bro, baseball is bro. You talk with me. And see 20.
Oh, wow.
Okay, well, how high you gonna do next week?
I mean, I did this before, but like in like a different like thing. It was like much bigger. Everything. The larger, like the smaller surface area, the harder. Right?
Not sure. So this is something I do the methods.
Oh.
So if that's simple, I think these right, will be normal. Kids are too much reading. And they will have much less matter. So if I match the bottom, right? Most likely everything is matched with the
It really prepares one thing.
challenge. 20 chips. 20 chips that are high with
I need to go for it.
go for it.
Go for it. I will say I want to go, but I'm gonna embarrass myself. 100%.
Not that hard. 20 chips only.
You do not have lemon chip.
Okay, let me demonstrate.
Demonstration, lemon. There's a chair over there. But there's literally a chair over there. Just grab it. Wait, Mr. Gabriel. It's a bit weird. No, this is not I have one. Hey,
Okay, that was it.
Wait, yeah.
Yeah. Okay. Okay.
Oh my god.
If I didn't stop for the accident.
Oh, this is so.
Okay, 20. You have three. Something you okay. Okay, wait, let me call you now first.
Okay, this is gonna be very cool, very interesting.
See,
The secret. Oh, Jonathan Horton will be chilling.
pay attention. Next time you.
You can do a whiskey. Totally.
Okay, we
1, 2, 3, 4, 1. Oh! Oh, no.
I'm not. I will do it.
We'll clean it up later, don't worry. Oh no, oh no. Duncan. I got off with it.
But it includes. Okay.
I'm not going to let's do this. Wait, I'm going to
Is it 20 or not?
I don't know. It doesn't tell.
one more mistake. Yeah. Navigated. Yes, thank you. Good question about it. Okay, so. Taking else, is that one? Okay. Ready? Okay, let's go. I'm going. As long as how you agree, okay. I don't watch. Good. Good. Yeah, oh, yeah, I'm really excited with your question now. Right? Challenge. It's not that bad, trust me. You did find the experience speaker. The speaker. Hey, one is missing. Oh, yeah, the one is missing for that. Yeah, there's two is missing, lah. Can I do the. That was the speaker. The speaker. The speaker of maths. Okay, so I go Shishia. Thank you for it. Thank you. Yeah, we got close to that. Okay. The value is exactly. Okay, ready? Go. Yeah. Yeah. You need to hold this flat onto the table, right? And then it's distance right? And then you do the cut. Yeah, you keep saying something like this. The don't I just but如果是个哪？等一下看你们打。I'm going to laughing yourself. No, no, no way. Okay, I think so. Okay. Oh, really? Oh, good. Come on. This is me out. Oh. Oh, it's not all the way there. Can you get it? Yeah. Oh, if you don't break it will break. It was gonna take fall damage in real life. Right. I need it. Good.
ears can't hear anything. No.
It's get us opinions for you.
Nothing.
I was really. Okay. Really. Then when you get from the all the things that people until it doesn't figure all the yeah, and on and see how it's in the sleep and how I sleep. The two same time can see the in bar, same like so it's not the difference by 4 people. Yeah. Oh. I got came up from this that I convert them. No, I can't that bro. And that 28 maximum right this yeah, sitting and yeah, what do you say? Noise, not good. And it's not fall on this, right? The outcome is lost. Be really funny. Second is one. I don't really go hard. You want to try? Well, I think so. Maybe was basically like 80% was 80%. So, miniatures. So, oh my God. It's not oh my God. Okay. That's really fun. Okay, this is our yeah. Well, I didn't okay. Ah, but when you go, here, from the type of second, I see. More. We don't need to go through these things. So if it's one, my second, I see. Hey, you want to see that? You understand? It's not the, it's not the, okay, you know. Oh, I don't know to do it. Oh. You want this. But it's like, I don't. You got to of fiction, you know, it's funny for okay. Okay, you want to see it? Take a pictures. Yeah, we don't think so. We get a 6 Alright, let's try it. You want almost almost yeah, I'm ready. Right, here's the okay. So it's right. Those learn. There's so that yeah, yeah. You must be there's so many office. Can that is second like as plan of the benefit ready now? Number one. Yeah. Oh boy. Oh. It's momentum and momentum. It's momentum. It's about but then number one. I mean, this is it's a reason to really so it's really how it is. Oh, oh, I shall be taking the record. Get up, man. Get down. So, sorry, then the non thoughtful is considered big, but you need the no, I know. I'm the angry. It's like I think but it's surrounds and now back down the road. They use that. I'm being paid. You tell them. That's down. That's the big one. No, yeah. It's very good. You know, it's in this is thing. Good. I mean, think of another. No. Oh no. Oh, because people. Oh, no, no, come on. Hey, let's oh, oh, oh no, no, no. That's going nice. Oh, oh, you don't know how much. Yeah, come on. Okay, let's go. Hey, no, no, oh, you got to go. Did you go Saturday? No, I really. I'm gonna be confidently. Very small. I'm going. But I want. They should know I can see. Look back. Pass it over. See chicken. See chicken. Okay. Ready on my Really well. Let's go. Yeah. Right. No, yeah, okay, the mouth. You know, hey, who's this? Oh, sorry.
All right, thanks for me to head of the bar.
Oh, by the way, oh, wow. I put it to work, shall we? I don't just have to. 你不要管，你不要，你不要管，你不要把那个发很真。啊，你是顶高的。
Huh?
What?
What?
Why? Okay. Okay.
Last piece. Last piece. But where's the class piece going to by like 30? The class piece in question.
Okay, guys, I'll see you all next week. Remember, bring the book, guys. Next week, we're going to move on to the new chapter already.
Let me drink my cocoa paste first. Cocoa paste? Yep. It's brown. It isn't Milo.
Okay, guys, I'll see you all next week.
Give it chocolate. Chocolate. Oh, thank you, thank you. It's okay. I don't have the onion missing this thing. Something can go. Machine, my mom is showing off fish. Bro, I'm packing that bag. Oh, what should I put this? My Pokemon cards. Yeah, you should put Pokemon card. Investor. Honestly, I try stuff. If I don't want to play, let's say we what? It's so much, sorry. I don't know if you know my man. I don't know. Yeah. Okay. Hey, yeah. Do you want to oh, I'll find you. Oh, Anyway.